Hello everyone, welcome back. As I said at the end of the previous video, we're now going to move on to conducting a more extensive phonemic analysis using some data from the O'odham language. So the O'odham language is a Uto-Aztecan language which is spoken principally in the United States in the state of Arizona. And I largely grew up in the state of Arizona. Although I'm not sure that I've personally known any speakers of this language. So the language has two dialects, which are sometimes referred to as Tohono O'odham and Akinel O'odham. Around the year 2000, there were probably something more than 10,000 speakers. I'm not sure if that situation in terms of number of native speakers has subsequently improved or gotten worse. But our goal right now, in any case, is to try to deal with a larger set of data, which is something to what you would see in a homework assignment. And we're going to be focusing on the following four sounds. So a voiceless alveolar stop, a palato-alveolar affricate, ch, and a corresponding voiced alveolar stop, da, and a voiced palato-alveolar affricate, ja. So the data that are here come from a dictionary of the O'odham language. And here we've just extracted some word forms from that dictionary. And I find very often when students first see a larger set of data like this, oh, there are 22 words here. What are we doing? They ask themselves, what are we doing? What is going on? Where do I even begin to try to understand what's happening in this language? So I've already sort of limited the parameters of our investigation to say what sounds we're going to be concentrating on. But if you don't know exactly where you're starting, or you know that you're trying to conduct a rather full phonemic analysis from scratch for a language, a good first step is to try to identify all of the phones in the data. That is, try to identify all of the distinct sounds that we find in the data. So that means reading through each of these phonetically transcribed word forms and saying what the different sounds are. So in the first case, we have a verb, meaning turn around, bijim, we can read that. And so we find the following phones in the word bijim, for instance. So a voiced bilabial stop, a high front vowel E, a palato-alveolar affricate, j, and a labial nasal m. The vowel E occurs twice in this word. And so for each distinct sound that we find, we can add that sound to a table representing the vowel sounds on the one hand and the consonant sounds of the language. And we can classify the vowel sounds by height and by frontness, backness. And we can classify the consonants using typical place and manner descriptions. So if we were to do what I just did for word number one, bijim, we can come up with the following full system. So we have a set of vowels, E, U, O, and A, which contrast for length for each vowel. In case you're not familiar with this symbol which looks a bit like a colon, a doppelpunkt, but in the International Phonetic Alphabet is actually a little different, indicates that the preceding sound is long. So vowels can be either long or short in this language. And we find the following consonant sounds occurring in the data. As an exercise for yourself at home, you might try to systematically extract all of these phones as well. But in any case, we have labial stops, voiced and voiceless. We have a labial nasal, and we have the glide, the labial glide, wa. We have corresponding alveolar stops, voiced and voiceless, an alveolar fricative, alveolar sibilant fricative, and an alveolar nasal. we have these two palato-alveolar affricates, ch and j, a retroflex sibilant sh, then two palatal sounds, a palatal nasal nya, and a palatal glide ya, and finally a pair of velar stops, voiced and voiceless, a velar nasal, and a glottal fricative ha. So one could try to take any particular group of sounds and try to see if one could establish any complementary distributions. But usually in the way that phonologists will tend to work is that after having looked through some data, one gets a bit of an intuition, a general sense that, oh, perhaps there is a complementary distribution between a couple of sounds. We think, maybe I never saw a voiceless alveolar stop preceding an O. And if I have never seen that in my data, maybe that means that my voiceless alveolar stop is in complementary distribution with another sound. And very often it's sensible to think that sounds that are phonetically similar in crucial ways, in this case the alveolar sounds and palato-alveolar sounds, might well be allophones of a single phoneme. And so our question is to establish, in this case, what the relations are between these four sounds are. So again, if you were doing phonology in the wild, so to say, without the rules of the game having already been established by me, the questions would be a bit more open, but I've already said, all right, we're going to restrict our focus to these four sounds. In order to do this, I'm going to introduce another technique, which I'll call the method of local environments. And collecting the local environments for these four sounds means looking at the local context immediately to the left and right of each instance of that sound. And it can also be helpful to note, since the data is numbered here, to note exactly in which data points a specific sound occurs. So you'll see in the table at the top of page 9 on the handout, here I've made one column for each of our four phones in which we're interested, and each row in the table then corresponds to a local environment where the sound occurs. So for instance, let's go back to data point number 1, Beijing, for a moment, and there we find an instance of the voiced palato-alveolar affricate ja, and we see that the sound ja type that in there occurs between two e vowels in this case. So to illustrate the application of this method of collecting local environments, let's briefly try to collect all of the instances of ja. So I'm simply going to read through the data, and each time I see an instance of the sound ja, of this voiced palato-alveolar affricate, I will add it. I should also note, it looks like I forgot to include one sound in our list of phones here, namely the retroflex voiced stop da. So I should add that to the table here. So here under stops, under the retroflex column, you may want to write in the voiced retroflex stop da there. All right, let's continue looking for the affricate ja now in our data. So we have chuku, ki, chud, daksh, dodom, toha, tatam. Okay, so in the word ju, ki, there we'll also treat word boundaries as part of the local context. As you'll see, very often the very beginning or the end of a word can condition the application of phonological processes. So strictly speaking, of course, the beginning or end of a word is not a sound, but it's very often relevant for phonology, so I'll consider it part. Okay, so I'm going to also note where this occurred. So this environment between two e's occurred in data point number 1. Here, In data point number 17, the noun meaning rain, juki, we have ja at the beginning of a word preceding an u. In data point 18, we see it at the beginning of a word preceding the high central vowel I. In data point 21, we see it occurring at the beginning of a word preceding the high central vowel, but long. And that constitutes, yes, all four of the environments. Check this against the table, which I had already compiled. Those are all the instances of ja, the four distinct environments in which it occurs. A sound, there could be data points that show a sound occurring in the same environment that you had already collected, and in that case, it's not necessary to write the environment once again. So once you have the reason why it's helpful to collect these local environments is because phonological processes are very often locally conditioned. That is, the sounds immediately to the occurring immediately before or immediately after the sounds in which we are interested may be relevant for determining what happens. That was the case in the English example that we already saw, right? So here a sound, the interdental fricative th, provided the relevant conditions for the change of an underlying alveolar nasal into a dental nasal. So in that case, it was the sound to the right. The sound to the left, which in all of the examples here was a vowel, didn't seem to be relevant. And after you've collected local environments, you may already notice some patterns. And I'm going to suggest here that we first look at the right context in the data, the sounds occurring after the sounds in which we are interested. So if I just focus on the two affricates, the two palato-alveolar affricates, ch and ja, for the moment, I can see a pattern in terms of the phonetics of where they occur. Namely, we can see that this ja in the data we collected only occurs before a high vowel. So our high vowels in Ordam are I, and U, and ja only occurs before I, U, or I. It doesn't have all the possible high vowels there. And similarly for ch, we only find it before I, U, and I as well, long or short. Whereas I don't really see a discernible pattern in the left context in the data. So all four of the sounds, ta, cha, da, and ja, are allowed to occur at the beginning of a word, for instance. And we can also see that the two stops are attested before word boundaries, before glides, and before non-high vowels. So it does look like there's a sort of complementary distribution between the stops and the affricates. The affricates only occur before high vowels, whereas the stops can occur before the end of a word. They can occur before non-high vowels, and they can occur before glides. And when we say non-high vowels, that means both the mid vowel o and the low vowel a. So from this distribution that we see in our data, it's possible to make a simple and coherent generalization. And this is what we love to find when carrying out phonology. The generalization can be stated as follows. The palato-alveolar affricates occur before high vowels, and the alveolar stops occur elsewhere. So we introduced the concept of elsewhere in the English example above, and we can see it applies here as well. The sounds before which the affricates occur can be united using a phonetically coherent statement. They only occur before high vowels, but there's not a good way to unify a word boundary, a glide, and a non-high vowel. Those environments don't have common properties that we can unify with a set of phonological features very easily. And so this would tend to lead us to the conclusion that since we have established a complementary distribution, that means we are dealing with a limited number of phonemes, namely that the affricates are probably generated through a phonological rule. And in terms of using the concept of minimal pairs for trying to establish what phonemes are, we need to go a little bit beyond the notion of minimal pair in the strict sense. So it's helpful if there are any true minimal pairs in the data that are relevant for our sounds. There aren't in this case, and languages are not always so kind as to have constructed minimal pairs for our use in phonological analysis. But we can be a little bit more flexible and just look to see if two sounds occur in identical local context. And if we see that two sounds occur in identical local contexts, we can probably make the assumption relatively safely that they do belong indeed to different phonemes. So for instance, for the affricates ch and ja, we can find a couple of such instances. So data points 7 and 18, let's look at what word forms those are. So the word chikid and the word jiwid in 18, there we see the affricate occurring at the beginning of a word before a short high central vowel I. So the fact that ch and ja occur in identical local contexts suggests very strongly that the two affricates ch and ja belong to different phonemes. And I think there's one other similar case. Yes, if we compare data points 20 and 21. So in 20, we find, again, the affricates ch and ja occurring at the beginning of the word, in that case, before a long central high vowel. There are no such instances for ta and da, though there are some that differ only in the length of the following vowel. So for instance, let's compare data point 3 and data point 13. So in 3 we have apan, but in 13 we have dagsh. So that's not even a perfect contrast in local environment, but they are pretty similar. The sounds ta and da are occurring at the beginning of a word before a low vowel, differing only by length. That's not great, but overall, given that we can establish that the affricates probably belong to different phonemes, and the affricates both occur in the same, systematically occur in the same context, and the stops, ta and da, never occur in that context, we can draw the following conclusions, namely that the voiced and voiceless palato-alveolar affricates occur in complementary distribution with the alveolar stops, and on the basis of the local environments in which the palato-alveolar stops occur, we can assume that the voiceless and voiced pairs belong to distinct phonemes. So the distinction between ch and ja is a distinction in the future voice. So that means we need at least two different phonemes. We're going to have one phoneme for the voiceless sounds, and we're going to need a second phoneme for the voiced sounds. And given that we were able to establish the context in which the palato-alveolar affricates ch and ja occur as before a front before a high vowel, that means we can take the stops to be the elsewhere allophone. Remember, we said they can occur before the end of a word, before a non-high vowel, and also before a glide. We have at least one instance in the data. And since the alveolar stops constitute the elsewhere allophones, then that means we should probably choose for the representation of our phoneme the elsewhere allophone, and that would then be the stop. So the result then are the following phonemic relations. So we have underlying phonemes of alveolar stops, a voiceless and a voiced alveolar stop, and each of those phonemes has two allophones, so an allophone identical to the underlying sound and a corresponding palato-alveolar affricate. So I think that's fairly straightforward. So before we finalize this analysis by trying to construct a phonological rule, which will derive the palato-alveolar affricates and perhaps carrying out some derivations to check our analysis, I want to say a couple of words about the construction of such data sets. So in your textbooks and in lectures in this course, you will see many data sets like this set of data from the Ordam language. And one point that it's important to note is that the authors of our textbook and I myself are often do work of cleaning up the data, and we also try to organize the data to make the important points jump out, make the important points more salient. So you should assume that if you're supposed to notice a particular generalization, the data will probably have been organized and contain a reasonable number of examples in order to illustrate the point. But often it's the case that the data simply aren't complete, that it's just not impossible, that it is simply not possible to find all of the relevant data. So for instance, in the Ordam data, the sound ch, we only find preceding the sounds short e, short I, long I, and short u, whereas while j is only found preceding short e, short I, and long u. So we don't have the complete set of high vowels in the data corresponding to each of these palato-alveolar affricate allophones. And I think for this data set, we have enough to reasonably draw conclusions. But in real life, if you were trying to write a paper, you should try to look for enough examples in order to be confident about your generalizations. So we've now drawn the conclusion as formalized in these diagrams here under point 8, that we think that the palato-alveolar affricate allophones of our two phonemes, ta and da, should be derived by rule. So in this case, we're going to say, as we've said, the stops constitute the elsewhere allophone, and we're going to use a rule to derive the affricates. I'll name this rule refers to the properties of the underlying sound, the alveolar stop, and it refers to what happens in changing that sound. So we begin with an alveolar stop and it becomes an affricate. For the moment, I'm using simple features. We could also call them fake phonological features, which just refer to the place and manner of articulation of sounds. And the input to our process, so here for these phonological features, we place them between square brackets, and this group of features puts together sounds that share some common properties. So the sounds ta and da are both alveolar stops. So we can say, we'll consider them to have the features plus stop and plus alveolar. They're distinguished in terms of the glottal state feature voice, ta being voiceless and da being voiced. And they are changed by the place features becoming minus stop and, the manner features becoming minus stop and plus affricate, and the place features becoming minus alveolar and plus palato-alveolar. And as we've seen, the context in which this change occurs is when the underlying alveolar stops are found preceding a high vowel. We'll use the feature plus syllabic to distinguish vowels from most consonants. So what this means in terms of choosing the underlying representation for words is essentially that whenever we find in the surface form of a word one of the palato-alveolar affricates, in its underlying representation, we should instead have the corresponding alveolar stop. So let's take 4 words as an example. So data point number 3, paapan. There, let me take my annotation tool. So in paapan, in the surface form of that word, we find a voiceless alveolar stop. So its underlying representation is going to be identical to its surface representation. In data point number 7, we have an affricate, and we have the voiceless affricate cha, and that should correspond to the voiceless alveolar stop. So the underlying form for this word should be tikid, and it's going to be output transformed into sometimes I have to wait for a moment to remember how to type the symbols. Underlying tikid is going to be transformed into chikid on the surface. There we have it. Moving on to number 13, dagshp. There, once again, we already have a stop on the surface, so the underlying representation is going to be identical to the surface representation. And number 1, we have a, it looks like there, I've given this, here we have an error. This should read bijim, right? Not bidim. Yeah, number 1 is bijim with that. So what you see on your handout already there corresponds already to the underlying representation. So let me clarify this. So here the underlying representation for data point number 1 will be bidim, and that will be output by our process of alveolar stop affrication as bijim. And we can give a couple of derivations now just to check that our process of alveolar palatalization works as expected. So let's try to put in the 4 forms that I've just now written here. So we can organize these a little bit. Let's clear those. So in terms of organizing this, remember how we want to organize a phonological derivation. We'll have an underlying representation. And maybe I think it will suffice perhaps just to show, I'll show the couple of forms using the voiced stop. So there for number 13, we'll have the underlying form that we've already seen, dash. And for number 1, we'll have the underlying representation bidim, and the only thing that we then need to see happen is the application of our rule of alveolar stop affrication. So through alveolar stop affrication, our rule of alveolar stop affrication looks for looks for an underlying D, which it finds here in BDIM. It also finds an underlying D in DAGSH. It would also look for underlying voiceless alveolar stops as well. And then it checks to see whether that sound occurs before a high vowel. So given that the vowel E is high, the conditions for the application are met. And so then underlying the BDIM is transformed into the BGene instead through our rule of alveolar stop affrication. And then finally, at the end of the derivation, we simply want to represent the surface forms. So in the case of DAGSH, nothing has changed. The underlying voiced alveolar stop DA remains as such. And we should put those forms in square brackets to indicate that we have a surface representation, and then for the other form, we have the word BGene, and those are our surface representation. Okay, so this shows a derivation for a couple of our forms. Remember, the structure of our derivation shows the underlying representations that we chose according to our analysis. Those underlying representations can only contain voiced alveolar stops, no alveolar affricates. Alveolar affricates are derived using the process shown in 7 here. And at the end of the derivation, we show the surface representations, which ought to correspond to the actual data. And indeed, data point number 1 reads BGene as we expect, and data point number 13 reads DAGSH as we expect. So this rule appears to be adequate. This rule of alveolar stop affrication appears to be adequate for generating the forms that actually occur in the data. So as a last remark, I'll just say to remember 2 assumptions about writing a rule using features in the way that I've done in number 7, namely that we're going to assume here that segments, the individual sounds like d, a, g, sh, and p, are clusters, groups of features. We'll talk about this theory again in a couple of lectures, but in other words, we're saying that those sounds are sort of the sum of their phonetic properties, and that rules, like the rule in 7, will change features which are specified, but leave all other features which are not specified unchanged. So for instance, this rule doesn't mention the glottal state feature voice, so it means that an alveolar stop, which is affected by this rule, doesn't change anything in terms of the feature of voice. The voice feature, if the sound going into the rule has the feature plus voice, it remains plus voice. And that's why this rule is able to generate both voiceless and voiced alveolar affricates. All right, so that concludes the lecture for this first week. I hope that this has been insightful and helpful for all of you. And for those of you following the course at the LMU, we'll see each other at 2 p.m. on Wednesday, also 14 Uhr über Zoom. Genau. Okay, good. So thanks everyone, and take care.